Managed grazing is not simply building fences to divide pastures and moving livestock from paddock to paddock. Managed grazing involves the careful consideration of the growth requirements and characteristics of the pasture plants, the needs of the grazing animals, the economics of the enterprise, and the daily decisions necessary to benefit each. A change in any one of the parts will influence the performance of the whole. This video focuses on the pasture plants, how they grow, their nutritive value, how they respond following grazing, and their role in some of the important grazing management decisions. To best manage the growth and use of pasture plants, you must first understand some of their basic needs and growth processes. Each plant in the pasture grows as an individual plant, responding to the environmental conditions around it. Among the most basic processes of the plant are photosynthesis, respiration, water and nutrient uptake, and growth. A plant generates its energy by converting sunlight to plant-usable carbohydrate energy in its leaf area. Generally, the more leaf area the plant has, the more efficiently it can accumulate energy. Closely grazed plants, or pastures with low plant density, are less efficient at capturing available sunlight. Plants first use their energy for respiration and basic maintenance functions. Energy is then used for leaf and root growth or seed production. Any excess carbohydrates which accumulate are available for regrowth. Plants absorb most of their mineral and water requirements through their root system. Plants with a large root system can efficiently absorb nutrients and water. However, plants with a limited root system have difficulty absorbing enough nutrients or water, even if they are abundant in the soil. Excessive leaf area removal by grazing greatly restricts the ability of the plant to support a root system. Maintaining a moderate to high level of leaf area will maintain a deeper and more vigorous root system. Growth can be defined as an increase in dry weight or yield, most often of the leaves, roots, and stems. If leaf area and photosynthesis is lacking, growth occurs very slowly. Remember that rapid growth and regrowth of pasture plants occurs only if the plants have good leaf area or good levels of accumulated carbohydrates. Plants usually grow through a normal growth cycle. A new shoot or a shoot which has been closely grazed has very little leaf area. It's inefficient at generating energy. It cannot support a large root system, and it grows or regrows new leaf area at a very slow rate. As the plants attain an optimum amount of actively growing leaves, they become very efficient at capturing sunlight and generating energy through photosynthesis. They can support an active root and leaf growth rate. Older plants with mature seed stems, or plants with older and less efficient leaves, slow or stop their growth. They often have an abundance of mature leaves and stems available for grazing, though this material may not be highly nutritious. Pasture grasses, legumes such as clover and alfalfa, and weeds all have the same general requirements and go through the same general growth rate phases. However, each individual grass, legume, or weed usually has its own unique leaf shape, growth habit, leaf arrangement, and responds to the environmental conditions of the site. Learning how different types of plants in your pastures grow and where new leaf or shoot growth will arise will help you evaluate pasture plants and make management decisions. If you look closely at pasture grasses, you'll see that there are only a few types of growing points or sites where new growth can develop. A tiller or shoot of the grass plant usually grows from the base of the plant. Tillers are compressed stems which produce a series of new leaves. The compressed stem has a growing point at its tip, which may continue to produce new leaves, or it may develop into a reproductive tiller and form a seed head on an elongated stem. The elongated reproductive stem becomes rigid and fibrous. Each leaf can produce additional leaf tissue during the several days that it's actively growing. At the base of each leaf, where it attaches to the stem, are buds that can potentially become branch tillers. Much of the summer regrowth of pasture grasses is new branch tillers emerging from the base of the plant. Tall, reproductive stems shade these basal tillers, particularly in late spring. and delay the development of new leafy basal tiller regrowth. If a reproductive tiller is grazed or clipped in the spring, several new branch tillers or shoots become productive and the grass stand becomes thicker with a greater tiller density. New grass tillers can also originate from buds on spreading, underground, root-like shoots called rhizomes of some pasture grasses. These satellite or daughter plants also contribute to a greater tiller density. The growing points of pasture legumes are also on individual shoots. In addition to the buds at the stem tip and at each leaf stem junction, many legumes also have dormant buds at the stem base, or crown, of the plant. These crown buds are the source of the first growth in the spring and can quickly produce new leafy regrowth when growing stems are grazed or clipped. Examples of pasture legumes with this growth pattern would be alfalfa, red clover, and bird's foot trefoil. Their growth habit is upright. As their stems age, the stems and plants as a whole become fibrous and unpalatable to livestock. The stems of white clover lie flat on the soil surface and spread by buds along the stem, forming stem branches. Pasture plants are managed to provide nutritious forage for grazing livestock. Different plant parts have different feed value. Plant leaves are highly digestible, high in protein, and generally palatable to grazing animals. Both grass and legume stems are fibrous and much less digestible than leaves. An exception may be the relatively young green stem tips of pasture legumes. The flat, upright leaf blades of grasses are more digestible than the more fibrous leaf sheath portion of a grass leaf. In mid and late summer, the vegetative leafy grass tillers have a significant amount of desirable leaf blades, but the lower tiller base, composed of cylindrical leaf sheaths, is more stem-like and of lower feed value. With an understanding of the growth of individual pasture plants and the relative nutritive values of their various plant parts, we can now consider the management of the pasture as a whole. The majority of the pastures in the upper Midwest are composed of mixtures of cool season grasses and cool season grass legume mixtures. Cool season pasture grasses are those that begin their growth in early spring and produce 40 to 60% of their seasonal growth before summer. They grow slowly through the warm summer months and again become productive during the cooler months of autumn. Most pasture legumes grow nearly as well during the summer months as during the spring and autumn months. Thus, the presence of legumes in pastures with cool season grasses helps to improve the uniformity of pasture growth and feed value throughout the entire grazing season. Some producers use warm season grasses in a separate pasture to supplement forage availability, particularly during the warm summer months. Warm season grasses produce 60% or more of their seasonal yield in June and July, a period when cool season grass regrowth rates are slow. The challenge for grazing managers is to monitor the growth rate and quality of the forage and to harvest it in a timely fashion with grazing animals or machinery. This needs to be done without wasting valuable forage or harming the vigor and growth of the plants. When managing a rotational grazing system, key decisions such as how long the livestock will remain on the current paddock, which pasture will be grazed next, and how long of a recovery period will be needed before livestock can return to a particular paddock must be made. These decisions are restricted somewhat by the system design. Fewer paddocks mean livestock must remain longer on each to allow a sufficient rest period for the remaining paddocks. When animals first enter a fresh paddock, they generally have abundant amounts of nutritious, leafy growth and generally consume as much as they can eat. After a few days, however, they become more selective in what they eat and often avoid the maturing seed stems in favor of the newly formed leafy tillers in the areas grazed a few days before. The greatest disadvantage of having too few paddocks is the extended grazing periods that requires. Left too long in one paddock, animals have an opportunity to eat the new regrowth from plants already grazed in that cycle. It takes a newly grazed plant 5 or 6 days to move stored carbohydrates to new growing points for regrowth to begin. Regrazing too soon will remove newly formed leaf area and greatly slow regrowth. The plant may also be nearly depleted of its carbohydrate reserve. A more desirable rotation system would be one with more paddocks allowing for livestock movement at 4, 3, or even 2-day intervals. This provides the livestock frequent access to fresh, highly nutritious, leafy forage and limits the chance for the selective grazing of new regrowth. The length of grazing time on any individual paddock has animal nutrition considerations as well. The forage on the first day in a new paddock is generally both high in feed quality and quantity. By even the second or third day, grazing animals must be less selective in their diets, with an increasing intake of lower quality stems and leaf sheath material. A grazing system designed with more paddocks for frequent moves is more desirable for livestock classes with high daily intake and quality requirements. A great complicating factor in the upper Midwest is managing for regrowth of pasture forage in the varying temperature and rainfall patterns of the area. Cool season grass pastures have very rapid growth and regrowth rates in the spring. They're often able to recover to a grazable condition within 15 to 25 days when growing conditions are favorable. Fewer paddocks with shorter rest periods are most appropriate for this period of the year. However, as temperatures increase and soil moisture decreases in the summer months, pasture recovery is much slower. A rest period of 35 to 45 days may be more appropriate during midsummer. A number of alternatives exist to provide for longer rest periods and slower regrowth rates. These alternatives include adding additional paddocks, leaving more leaf area following grazing to provide more rapid regrowth, maintaining some legumes with the cool season grasses, staying longer on each paddock, supplementing livestock diets with hay or grain, and maintaining some warm season grass paddocks strictly for summer grazing. Fresh forage is at the heart of a successful managed grazing system. Mastering the management skills necessary to keep that forage vigorous and high quality is the key to a profitable pasture livestock enterprise.
Sure, there's a science as to when exactly for the leaf is the best time to have it grazed. And then the art side of it is, well, we only have so many paddocks that are ready to be grazed. Which one do they go to next? They have to go somewhere, whether that paddock's exactly ready or not. So I simply look for whichever paddock is most ready to be grazed based on, the leaf area, the grass height. I prefer to put them on a good leafy paddock and not a stemmy paddock. So height is only part of the equation. The other is leaf equation. And the weather conditions play a role too. If it's really hot and dry and I know that those paddocks haven't gotten sufficient rest, then I might not put them in that paddock yet. I might keep them on a sacrifice paddock a little bit longer and feed them some hay just to get those other paddock areas ready to be grazed.